So another very important topic for exam purpose, measures of central tendency. Okay, next we are going to see the regression, correlation and dispersion. Right? Central tendency, there is a peculiar tendency of the data to cluster or center around a specific value. On the whole, they tend to be closer to one particular value than others. This peculiar tendency of a data is called central tendency. Okay. So here first we'll see what is arithmetic mean and its computation. There are 6 types of fundamental measures of tendencies. Okay, arithmetic mean, median, mode, geometric mean, harmonic mean, then weighted averages. Right. So arithmetic mean and its computation. This is the most commonly used measure of central tendency, popularly called average or mean. Arithmetic mean, or popularly called as average or mean. Or a sacrist. Arithmetic mean is the amount secured by dividing the sum of value of the items in a series by their number. It's the sum of values of the items in a series by their number. Arithmetic mean is the amount secured by dividing the sum of values of the items in a series by their numbers. The student should add all the observations together and divide this sum by a number of observations. Then we'll get a arithmetic mean. Suppose we have an observations, ungrouped data or measures x1, x2, x3. x1 plus x2 plus x3 plus xn divided by n. Okay. X bar is equal to, that is mean, is equal to summation of x1 divided by n. Okay, the formula will be the mean of x is equal to summation of x, okay, divided by n. This is the mean formula. This method is called as direct method. A variable takes the value is given, will calculate the arithmetic mean of 110 summation kottidare. So we need to add all the observation, divide by how many observations are there. Then we'll get a arithmetic mean. Next, find the mean of the following 50. There are 50 if suppose there is a 50 observations, then we may need to make the tabulate the given observation as follows. Okay, so 50 observations. ತುಂಬಾ observations ಇದ್ದಾಗ we need to tabulate ಅದನ್ನ ಒಂದು ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಬಿಟ್ಟು ಒಂದು ಮ್ಯಾನೇಜ್ ಮಾಡೋದು. So there are 17 ಎಷ್ಟು ಸಲ ರಿಪೀಟ್ ಆಗಿದೆ observations, we need to write it down. 17, 18, 19, 20, 21, 22, 23. So 23 ತನಕ observations ಮಾಡಿ, how many times frequency has been done? 3, 6, 11, 12, 28, 11, 1. So frequency, summation of frequency is 50. Then fxi, okay, fxi is equal to, that you have to multiply observation with the frequency, we'll get fxi, that is equal to 981. So arithmetic mean is fx, summation of fx divided by f, okay, is equal to 981 divided by 50. Here very important is the tabular form ಅಲ್ಲಿ ಮಾಡ್ಕೊಳ್ಳುವಂಥದ್ದು. Okay, arithmetic mean ಅಲ್ಲಿ tabular form ಅಲ್ಲಿ ಮಾಡ್ತಾರೆ. It's a direct method. Mean for grouped data. This were ungrouped one. Okay, continuous series. The procedure of finding the arithmetic mean in the series is the same as we have discussed earlier. The only difference is that we are given class intervals whose mid values are to be calculated. Okay. So the phase in the 30 articles are given. 30 articles ಅಂತ ಕೊಟ್ಟಾಗ ಅದನ್ನ ನಾವು ಒಂದು tabular form ಅಲ್ಲಿ ಮಾಡ್ಕೋತೀವಿ, but it is a ungrouped data. It's a grouped data. Okay, so 11 to 13, for 13, 14, 15, 17, 17 to 19, 19 to 21, 21 to 23, 23 to 25. So ಇಷ್ಟು weights ಅನ್ನ ಮಾಡ್ಕೊಂಡಿದೀವಿ. ಮಿಡ್ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ವಿ. 12, 14, 16, 18, 20, 22, 24. Frequency 3, that is 11 to 13 ಎಷ್ಟಿದೆ, right? 1, 1, 11, okay, 12, here also 11, 3 times ಇದೆ. So 11 to 13, mid value is 12 and frequency 3. Next coming to the 13 to 15 ಎಷ್ಟಿದೆ, 15 to 17, 17 to 19, they identify ಮಾಡ್ಬಿಟ್ಟು we need to add on that, in summation of f will get is equal to 30. For direct method we need to multiply mid values with the frequency, we'll get a direct method fi xi. Okay, so that is equal to 540. So shortcut method, this is not needed. Okay, this is not needed, right? This is not needed. So you need to focus on this one, direct method. Okay, direct method you need to focus. So summation of fi xi, that is 540 divided by 30, then we'll get a mean is 18. Mean weight is 18 grams. Okay. ಇನ್ನು ಇಲ್ಲಿ ಟ್ಯಾಬ್ಲರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿಲ್ಲ, ನಾವೇ ಟ್ಯಾಬ್ಲರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಒಂದು ಗ್ರೂಪ್ ಮಾಡಿಕೊಂಡು ಒಂದು ವೇಸ್ ಅನ್ನು ಸಪರೇಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. So find the arithmetic mean for the following. Properties of arithmetic mean ಅಂತಂದ್ರೆ sum of the deviations of all the values of x from their arithmetic mean is 0. Sum of the deviations of all the values of x from their arithmetic mean is 0. The product of the arithmetic mean and the number of items given the total of all items. If and are the arithmetic mean of two sample sizes n1 and n2 respectively, then the arithmetic mean of the distribution combining the two can be calculated as. So illondu formula kottidare, that is x bar is equal to n1 x1 plus n2 x bar 2 divided by n1 plus n2. This one is for arithmetic mean of two sample sizes n1 and n2. Okay, n1 and n2. I hope you can see that x bar, okay, x bar is equal to, okay, n1 x1 bar plus n2 x2 bar divided by n1 plus n2, right? So this is the if and are the arithmetic mean of two samples of sizes n1 and n2 respectively, then arithmetic mean of the distribution combining the two can be calculated as this. ಈ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಮಾಡ್ತೀವಿ ಅಂತ. ಓಕೆ, ದೆನ್ ಮೆರಿಟ್ಸ್ ಆಫ್ ಅರ್ಥಮೆಟಿಕ್ ಮೀನ್. ಮೆರಿಟ್ಸ್ ಆಫ್ ಅರ್ಥಮೆಟಿಕ್ ಮೀನ್ ಅಲ್ಲಿ ಇಟ್ ಇಸ್ ರಿಜಿಡ್ಲಿ ಡಿಫೈನ್ಡ್. ಇಟ್ಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಆಲ್ವೇಸ್ ಡೆಫಿನೆಟ್. ಓಕೆ, ಸೊ value is always definite and it is easy to calculate and easy to understand, hence it is very popular. It is rigidly defined and value is always definite, and it is based on all the options so that it becomes a good representative. Okay, it can easily be used for comparison. It is capable of further algebraic treatment such as finding the sum of the value of the observations if the mean and the total number of the observations are given, finding the combined arithmetic mean when different groups are given. It is not affected much by the sampling fluctuations. Okay, it is not much affected by the sampling fluctuations. It is capable of further algebraic treatment such as finding the sum of the values of the observations if the mean and the total number of observations given, finding the combined arithmetic mean when different groups are given. Okay, it is not affected much by the sampling fluctuations. Demerits of the arithmetic mean. Here we can see that it is affected by outliers or extreme values. Okay, it is affected by outliers or extreme values. In such a case, mean is not a good representative of the given data. Outliers ಅಥವಾ extreme values ಇದ್ರೆ ಅದು affect ಆಗುತ್ತೆ. It is always its value which may not be present in the given data. Many times it gives observed results like 4.4 children per family. Sometimes it gives observed results. It is not possible to take out the average of ratios and percentages. Ratios and percentages we can't calculate it when open end class intervals are given. Okay, closed ended okay, open class intervals are given, then we can't calculate the arithmetic mean. Okay, so weighed arithmetic mean and its computation. When individual observations vary in importance, then there are assignments like level of importance of each in the computation of their mean. The arithmetic mean of the set of observations computed by taking into account of their corresponding weights is known as weighed arithmetic mean or average. Okay, weighed arithmetic mean or average. A weighed arithmetic mean is equal to a plus wxi divided by wi. That is, weighed arithmetic mean is equal to arithmetic mean is equal to A, okay, plus Wi xi divided by Wi. Okay, this is weighted average mean formula. Then geometric and its computation. Okay. Geometric and its computation. This is also important. The geometric mean of a set of n sample observation is the root of their product. That is square root of geometric mean is the square root of x1 into x2 into xn. Okay, square root of in the idrulli 2. Okay, x1 x2 x1 into x square into, okay, gm is equal to square root of, here it is one, square root of x1 into x square into so much of this thing, then x n. Okay, x n. When n is more than 2, so antilog of log xi divided by n. Weight geometric mean is equal to antilog of wi log xi and wi. Okay. So GM is particularly used in averaging ratios and percentages. That is, geometric mean is used for ratios and percentages and rates of changes in one period to another period. Then harmonic mean, ಇದನ್ನ just formula ಕೇಳಿದ್ರೆ ಇದನ್ನು 3 marks ಕೇಳಿದ್ದಾರೆ. Okay, harmonic mean ಅಂದ್ರೆ ಏನು ಅಂತ? Harmonic mean and its computation. It is defined as the reciprocal of the arithmetic mean of the reciprocal of the given set of observations. Then harmonic mean is denoted as, okay, n divided by summation of 1 by xi. Okay, n divided by summation of 1 divided hm is equal to harmonic mean is equal to, this is a reciprocal of the arithmetic mean. Arithmetic mean ಏನಿತ್ತು? Okay, fxi divided by f ಅಂತ ಇತ್ತು. So that is n. So n divided by summation of 1 by xi. Weight ದಲ್ಲಿ wi divided by wi xi. So harmonic mean is particularly useful in average rates and ratios. Okay, average rates and ratios. It is appropriate average where the unit of observation such as per hour, per day remains the same. The act being performed, that is covering distance, is constant. So calculate average rates of ratios and find out ಮಾಡಬೇಕಾದ್ರೆ we use this formula. hm is equal to n divided by 1a plus 1b plus 1 by c. So this formula we will use in the harmonic this thing to find out per hour per day calculations. N divided by 1 by a plus 1 by b plus 1 by c. So Ravi drives car 20 km per hour for first half an hour journey, 30 km per hour for the second half. What is the average speed ಅಂತಿದ್ದಾಗ n ಎರಡು ಕೊಟ್ಟಿದ್ದಾರೆ. So 20 and 32 ಕೊಟ್ಟಿದ್ದಾರೆ. n is 2 here divided by 1 by 20 plus 1 by 30, that is 2 divided by 0.0083, that is 24 km per hour. Okay, ಇದು ಒಂದೊಂದ್ಸಲ ಕೊಟ್ಟಿರ್ತಾರೆ ನಿಮಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ, ನೋಡ್ಕೊಂಡಿರಿ ಕ್ವಶನ್ ಈ ತರದ್ದು ಬೇರೆ ಬೇರೆ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ. Okay, then coming to the median. Median ಅಂತಂದ್ರೆ ಏನಿರುತ್ತೆ? It is the value of the size of the central item of the arranged data, arranged in the ascending order or descending order ಅಲ್ಲಿ ಮಾಡಿ center point ಅನ್ನು ನಾವು median ಅಂತ ಹೇಳ್ಬೋದು. It is the value of the middle item. Okay, divides the series into two equal parts, and Canar's words, the median is the median is that value of the variable which divides the group into two equal parts, one part comprising all values greater and the other all values lesser than the median. Okay, 7 workers to namge wages find out ಮಾಡಬೇಕಂದ್ರೆ first we need to arrange it in the ascending or descending order, then we'll find a middle one, that is median. Set the individual series either in ascending descending order, then you have to find the middle value. Okay, if n is odd number, okay, if n is odd, the median is equal to size of the n plus 1 divided by 2 the observation. If n is even, the median is, so ಇದರಲ್ಲಿ ಎರಡು ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. ಓಕೆ ರೈಟ್. if m ಅಲ್ಲಿ ಆಡ್ ನಂಬರ್ ಇತ್ತಂದ್ರೆ n plus 1 divided by 2 is the formula. Okay, n plus 1 divided by 2 is the formula for odd this thing. If it is odd numbers ittantandre, okay, median is equal to n plus 1 divided by 2 the ಇದನ್ನೇ ನಮಗೆ ಮೀಡಿಯಂ ಆಗಿ ಸಿಗುತ್ತೆ ಅಬ್ಸರ್ವೇಷನ್ ಅಲ್ಲಿ n plus 1 divided by 2th this thing. If it is a even number, okay, if it is even number, then median is equal to, okay, 1 by 2, formula is 1 by 2 n by 1 by 2th observation plus size of the n by 2 n plus 2 divided by 2th observation. Okay, so n by 2th observation plus n plus 2 divided by 2th observations. So the following, these are the even, if n is even, the median is 1 by 2, that is n by 2 tooth plus n plus 2 by tooth observations. So we can call it as median. The following figures represent the number of books issued at the counter of a statistics library on 11 different days, that is 96, 180, 98, 75, 270 up to 200. Calculate the median. ಕೊಟ್ಟಿದ್ದಾರೆ ಒಂದು. ಸೊ ಮೀಡಿಯನ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ಏನಾಗಿದೆ 70, there is odd number, so n plus 1 divided by 2th item is the median. Okay, so if there are the population n,000 of 36 metropolitan cities, because it's a even number, we need to calculate 1 by 2 size of the n by 2. So n is 36 by 2th item plus size of n plus 36 plus 2 divided by 2th item, that is 18th item plus 19th item, will get a 1 by 2, 213 plus 239, that is equal to 1 by 2, 552, that is equal to 276,000. So this is how we can calculate the odd numbers iddaga median anna find out ಮಾಡೋದು. Okay, size of the n by 2th item plus size of the n plus 2 by 2th item. So median in discrete series steps: arrange the cumulative frequencies, find the cumulative frequencies, apply the formula. Okay, median in discrete series ಅಲ್ಲಿ ಅದು ಕಂಟಿನ್ಯೂಸ್ ಅಲ್ಲಿ ಬಂತು, ಇದು ಡಿಸ್ಕ್ರೀಟ್ ಸೀರೀಸ್ ಅಲ್ಲಿ ಹೇಗೆ ಮಾಡ್ತೀವಿ ಅಂತ. ಸೊ ಅಪ್ಲೈ ದ ಫಾರ್ಮುಲಾ. ಇಫ್ n is equal to summation of fi, then median size of the n plus 1 by 2th item. Okay, ಇಲ್ಲಿ ಸೇಮ್ ಆಡ್ ಇದ್ದಾಗ ಸೇಮ್ ಇದೆ, ಸೇಮ್ ಫಾರ್ಮುಲಾ ಇದೆ. ಬಟ್ ಇಫ್ ಇಟ್ ಈಸ್ ಈವನ್ ಇತ್ತು ಅಂತಂದ್ರೆ n by 2 size of the n by 2th item plus size of the n by 2th plus 2th item. ಸೊ ಡಿಸ್ಕ್ರೀಟ್ ಸೀರೀಸ್ ಅಲ್ಲೂ ಇದೇ ತರನೇ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಆಗುತ್ತೆ. Okay, median ಗೆ locate the median of the following distribution. Following distribution median ಯಾವುದು ಅಂತ. First we need to find out the size, then frequency, then we need to find a cumulative frequency. Cumulative frequency ಅಲ್ಲಿ 3 ಇತ್ತು, ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ನಾವು ಆಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. 3 plus 7 10, 10 plus 12 22, ಇದರ ಆಡ್ ಮಾಡ್ಕೊಂಡು ಕ್ಯುಮ್ಯುಲೇಟಿವ್ ಫ್ರೀಕ್ವೆನ್ಸಿಯನ್ನು ಫೈಂಡ್ ಮಾಡ್ತೀವಿ. ಫೈಂಡ್ ಮಾಡಿ the median is equal to size of the n plus 1 by 2th item, size of the 75 plus 1th divided by 2 item, that is size of the 38th item. In the order of cumulative frequency, the 38th item is present in the 50th cumulative frequency whose size is 40. Therefore the median is 40. Okay, median in continuous series grouped ಅಥವಾ grouped ಡೇಟಾದಲ್ಲಿ ಹೆಂಗಿರುತ್ತೆ ಅಂತಂದ್ರೆ determine the particular n by 2th as the rank of the median are not n plus 1 by 2. After the ascertaining the classes in which the median lies, the following formula used for the determine the exact value of the median, that is L1 median find ಮಾಡಬೇಕು. L1 plus in the bracket n by 2 minus CF divided by F, L2 minus L1. Okay, So L1 is the lower limit of the median class, L2 is the upper limit of the median class. So L2 minus L1. Okay, F is the cumulative frequency of the class preceding the median class. F is the sample frequency of the median class. It should be noted that while interpreting the median value of the frequency distribution, it is assumed that the variable continuous and there is an orderly even distribution of the items within each class. ಓಕೆ ನಿಮಗೆ ಯಾವ ಥರ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಅದನ್ನ ಒಂದೆರಡು ಸಲ ನೀವು ಸಾಲ್ವ್ ಮಾಡಿದ್ರಿ ಅಂದರೆ ಅದ್ರ ಬೇಸಿಸ್ ಮೇಲೆ ಯು ಹ್ಯಾವ್ ಟು ಪುಟ್ ಅ ಫಾರ್ಮುಲಾ, ಯಾವ ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತ. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ಟೇಬಲ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಏಜನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ, 22 25 25 to 30 30 to 35 ಅಂತ ಕೊಡ್ತಾರೆ. ಸೊ ಎರಡು ಕೊಟ್ಟಿದ್ದಾರೆ, ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಆ್ಯಂಡ್ ಹೈಯರ್ ಲಿಮಿಟ್ ಕೊಟ್ಟಾಗ ಯು ನೀಡ್ ಟು ಯೂಸ್ ದಿಟ್ ಇಟ್ಸ್ ಅ ಗ್ರೂಪ್ ಡೇಟಾ ಅಂದ್ಕೊಂಡು ಕಂಟಿನ್ಯೂಸ್ ಸೀರೀಸಲ್ಲಿ ಯು ನೀಡ್ ಟು ಯೂಸ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. ಓಕೆ, ಕ್ಯುಮ್ಯುಲೇಟಿವ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಹೇಗೆ ಕಂಡಿಡಿದ್ರೆ ಸೇಮ್ ಇರುತ್ತೆ. ಮೀಡಿಯನ್ ಅನ್ನು ಫಸ್ಟ್ ಫೈಂಡ್ ಮಾಡ್ತೀವಿ, n/2 ಐಟಮ್ ಹೇಗೆ ಬರುತ್ತೆ ಅಂತ, ದಟ್ ಈಸ್ 30 to 35 ಕ್ಲಾಸ್ ಇಂಟರ್ವಲ್ ಅಂತ ಬರುತ್ತೆ, 250th ಐಟಮ್ ಅಂತ. ಮೀಡಿಯನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು L1 L2, ಇದನ್ನ ಹಾಕಿ ಏನು ಬರುತ್ತೆ 32. ಇದರೊಳಗೆ ಯಾವುದು ಎಕ್ಸಾಕ್ಟ್ ಯಾವುದು ಅಂತ ಗೊತ್ತಿಲ್ಲ ನಮಗೆ. ಓಕೆ, 30 to 35 ಅಂತ ಗೊತ್ತು, ಬಟ್ ಎಕ್ಸಾಕ್ಟ್ ಗೊತ್ತಿಲ್ಲ, ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಕ್ಕೆ ದೆನ್ ಅಗೇನ್ ವಿ ಆರ್ ಪುಟಿಂಗ್ ಮೀಡಿಯನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು L1 ಪ್ಲಸ್ ಈ ಫಾರ್ಮುಲಾ ಹಾಕ್ತೀವಿ. ಇಲ್ಲಿ L1ಗೆ 30 ತಗೋತೀವಿ, L2ಗೆ 35 ತಗೊಂತೀವಿ. ದೆನ್ n/2 cumulative frequency we got it as 150. Okay, then f is equal to 180, right? F is equal to 180. Then therefore median is equal to this much, 32.78 years. Note that while calculating the median of series, it must put in exclusive class interval form. Okay, exclusive class interval form. If the original series is in inclusive type, first convert it into the exclusive type, then find its median. So ಈ median find out ಮಾಡೋಕ್ಕೆ exclusive class interval form ಬೇಕಾಗಿರುತ್ತೆ. Okay, exclusive class interval. So exclusive class interval form, if the original series is in inclusive type, first convert it into the exclusive type and then find its median. Merits of median. Merits of median ಅಲ್ಲಿ ಏನು ಬರುತ್ತೆ, it is rigidly defined and it is easy to calculate and understand. It is not affected by the extreme values, but arithmetic mean is going to affected by the extreme values, but it is not affected by the extreme values. Okay, can be found by mere inspections, fully representative and can be computed easily, can be used to qualitative studies ಅಲ್ಲಿ use ಮಾಡಬಹುದು. Even if the extreme values are unknown, median can be calculated. One can know the number of items. It can be obtained graphically. Demerits of median ಅಂತಂದ್ರೆ it may not be representative of the distribution. Okay, not capable of further algebraic treatment. Okay, not based on all the observations, affected by the sample, it is affected by the sample fluctuations. Okay, it is in arithmetic mean it is not affected by the sample fluctuations, but medianally it is affected by the sample fluctuations. The arrangement of the data in the order of magnitude is absolutely necessary. Then check your progress. Okay, next coming to the mode. Okay, coming to the measure of dispersion. Measure of dispersion ಇಲ್ಲಿ mode ಅಂತ ಕಂಪ್ಲೀಟ್ ಮಾಡೋಣ. It is the size of that item which possesses the maximum frequency. Maximum frequency ಇರೋದನ್ನೇ ನಾವು mode ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. According to Professor Kenne and keeping, the value of the variable which occurs most frequently in a distribution is called mode. It is most common value. It is the point of maximum density. So locate the mode in that 7 12 8 5 9 6 10 9 4 9 9 9. So 9 is the mode because 9 is maximum, having a maximum frequency. Okay, send grouped data antidre determine the model class which has the maximum frequency. By interpolation the value of the mode can be calculated. Here ಅಲ್ಲಿ ಒಂದು ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ವಲ್ಲ, ಸೊ ಮೋಡ್ ಅನ್ನ ಇಲ್ಲೂ ಇದೇ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ಬೋದು. L1 minus F1 minus F0 divided by 2F1 minus F0 minus F2 L2 minus L1. Okay, frequency of the model class, frequency of the class preceding the model class, frequency of the class succeeding the model class. So merits of the mode ಅಂದ್ರೆ it is the simple to calculate, discrete distribution, individual or discrete distribution can be located by mere inspection. It is easy to understand. Everyone is used to idea the average size of the garment. It is not isolated like the median. Okay, median, as it is the most common item. Like the average mean, it is not a value which can be found in the series. Okay, it is not necessary to know all the items. What we need, the point of maximum density frequency, not affected by the sampling fluctuations. Mode is not affected by the sampling fluctuations. The demerits, it is ill-defined, not based on all observations, not capable of further algebraic treatment, not good representative of the data. Sometimes there are more than one values of the mode. So relationship between the mean, mode and median is important agutte. Okay. So in the symmetric distribution, mean, median, mode have the same value. Relationship is AM is equal to GM is equal to HM. All are equal. But usually the frequency distribution tends to be deviate and get skewed. Positively skewed ittantandre distribution skewed, that as a result mean gains highest value followed by median and mode. Mean gets the highest value, then median, then mode. Okay. Negatively skewed ittantandre. Okay. So as a result value of the mean tends to be lowest valued, then follow the median value. All the three are empirically related, as mean minus mode is equal to 3 mean minus median is equal to mode, mean minus 3 mean minus median. Okay. Mean minus median is equal to 1 by 3 mean minus mode, and mode is equal to 3 median minus 2 mean. Okay. So ಯಾವುದಾದ್ರೂ ಒಂದು ನೋಡ್ಕೊಂಡ್ರೆ ಸಾಕು ಇದರಲ್ಲಿ. So what is my, I can see that mode is equal to, okay, mode is equal to 3 median minus 2 mean. 3 median minus 3 mean. Mode is equal to 3 median minus 2 mean. Okay. So ಇದನ್ನ ನೋಡಿ ಇದರ ತಕ್ಕಾಗೆ ಉಳಿದಿದ್ದನ್ನೆಲ್ಲ ಚೇಂಜ್ ಮಾಡ್ಕೋಬಹುದು. 3 median minus 2 mean. The comparison of the three measures, mean is the most familiar and widely used measure of the central tendency, is to take into account all the observed in its computation. The presence of extreme values affect the mean more than median and mode. Mean is used for symmetric distributions. Okay, mean is used for symmetric distributions, but the presence of extreme values affect the mean. Okay. Median is easier to understand compute when the data is relatively small. Small iddaga we can use as median. Okay. The extreme values don't affect the median more as such as mean. Therefore, it is frequently used as the best measure of central tendency as asymmetric distributions. Okay, median anna asymmetric distribution ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Mode is the least used measure of central tendency. It is very easy to compute. It can be used for both quantitative and qualitative data. A little care should be taken in computing mode because every distribution may not have mode. There may be two modes present in one distribution. Okay. So summary is, measures of central tendency are the basis of statistics. Central value of the given set of data and find out ಮಾಡೋದೇ ಇದ್ರದ್ದು main motive. There are three measures of central tendency: mean, median and mode. The other measures are geometric mean, harmonic mean. Mean is also called as average. Median is the location average of the middle value of the ordered array of set of observations. Mode is also location average, but it is the higher frequency rather than we need to select. Okay.